Good morning, Earth scientists. It is Tuesday. It is April 25th today. We're winding out the last week in April, and May is around the corner. So let's talk about today. We are going to wrap up the Kepler labs. So we are going to be tackling Kepler 3 today. Kepler 3 is nothing but essentially graphing. So we'll go over the answers for Kepler 2, because like I said, we would start off with that today. So we go over the answers for Kepler to make sure that we have all the correct answers. And then going into Kepler 3. Kepler 3 is all about the distance a planet is from the sun, the longer it takes to revolve. That's why it says the distance planets from the sun and its period of revolution are related. So the further it is, the longer it takes. So what we're looking at here is say this is Mercury, for example. It takes Mercury 88 days, 88 Earth days to go around the sun. And if this is Neptune, it takes Neptune, what was 137 Earth years to go around the sun. So that's kind of what we're looking at. So that is Kepler's third law. So some background information. This is all attached below. What's the period of a planet? What's Kepler's third law of planetary motion? Going through the questions. If you don't have a printer, you can, write this on a sheet of notebook paper. You can pause the screen where it's at. We have our question. Here is your answer. And as far as materials, everything's right here. It's a graph. So it says you're going to take the information on the following table and put it into a graph. You'll set up a graph with a horizontal axis, which is distance, going from 0 to 40. You're going to set up the graph with vertical axis, period, going from 0 to 170. We cut this down. Gee, why would we cut this down? Because Pluto is no longer a planet. So we don't need to go out as far as Pluto. So make the graph paper as large as possible, plot the points. So here are all the points that you'll be plotting. You have the period, so how long it takes to go around, and then the distance. And an AU is an astronomical unit, and that is the average distance between the Earth and the Sun. That's 1 AU, 93 million miles. So go through, you'll plot all these different points for all the different planets, and this is how you're going to set up your graph. So count by fives up to 170, count by twos all the way to 40. So you can pause the video here, make your graph look like this. And even if you don't have a printer, you could set this up on a sheet of notebook paper. And then you'll plot the points. Now, there are a couple questions here when you look at number 6 and number 7. So let's say we mysteriously find a planet that is 35 AUs from the sun. What would its period of revolution be? Or if we found a planet with a period of revolution of 130 years, what would the distance be? So I have a graph up here. Yours is going to look a little bit different than this, but this is just one I got from Google. The idea is once you get all your points plotted, you should be able to lay a smooth line on those. So in other words, if we were to find a random planet we didn't know it existed, you could come over here to like say 55 AUs, and you could go up and you could say, all right, right here, that the period of revolution would be like 425 Earth years. So once you lay that line down, this rule applies for all the planets. So that is that. Get that finished up. We have the Kepler quiz tomorrow. If you are not done with your Kepler labs, you could go back to last week's slides because we have the answers in all the slideshows. You could go back into the video from yesterday. We went over answers. At the start of this video, I went over answers. So all the answers are there for you to have your sheets completed and ready to go for tomorrow when we have the Kepler quiz. Have an amazing day. Reach out with questions. Be kind and take care.